Okay, student, to continue this example solution, we calculate and talking about KCL, KVL, we know the phi. No, my suggestion is to calculate the reluctance for this system, which is how we calculate reluctance. It's 1 over mu, 1 over mu, which is mu 0 times mu r, L, whatever LC or LG or whatever L, over A, correct? We can check it by here, which is correct. Okay, so even we can ignore the 1 by here, which is not very important, of course. Okay, then as you know, reluctance of the core or reluctance of the core length 40 centimeter, so 10 minus 2 converted to meter. Mu is mu 0. What is the value for mu 0? Mu 0 is 4 pi times 10 minus 7, or maybe your calculator, it is available in your calculator, means the value, times mu r. So mu r is given by here. Mu r is 4,000, correct? So this is 4,000. And the cross sectional is given as 12 square centimeters, so 12 times 10 minus 4. So by solving this one, you can calculate RC, and in the same way RG, which is the gap value, equal for the gap we have 0.05 times 10 minus is it millimeter, no, centimeter, minus 2, okay, over only mu 0, okay, correct? We don't have here mu r, and then times 12 times 10 minus 4. Based on calculation these values, our expectation is very clear. Rg must be much more bigger than Rc, but whatever, Rg is in series, so added to Rc. Let's see, and this is R equal, means reluctance equal, okay? Let's see the value. So this one is for the core. Rc is 66,300. So the value for Rc given as let me change it, 66,300. The value is ampere turn, or 80 over Weber. But what about the Rg? You can see 316,300 ampere turn, 80 over Weber. So as you can see, quite big. Then what is the next step? The next step is calculating. I think this asks you to find out the MMF. Okay, so MMF here is R, which is R equal times phi. We know phi, which is this value given by here. R equal also is very clear, 66,300 plus 316, 300. So the total value here is phi Ni over Rc blah blah blah. Okay, so the value is given by here. Then when we calculate the MMF, we know the formula. MMF is equal Ni equal HL equal reluctance phi. So then we know the number of turns, which is given by here. Number of turns is 400. So easily you can calculate what? The current, okay? What is the current value can produce this flux density? So the current can be calculated as 0.602. The values can generate such a this flux. This equation, this example, can be solved in another way. You can even calculate H. Okay, you can even calculate H value. What is the H value here? Then you can find it out. How? Then the L, of course, is clear, but how we can find H? This is a question. I leave it for you. Later in some example, you will see the calculation need to first calculate H on behalf of R. So it means we should using KVL on behalf of KCL. Okay. Next part is focus on this problem leakage flux. Okay. Before that, I explained that we usually ignore the fringing effect or leakage flux. Okay. Mostly our expectation since here until end of this unit, our expectation is there is no fringing effect as you can see by here, and all flux are perpendicular to the air gap, means from upper side to down or down to up. Okay, and there is no fringing and leakage effect. Whatever, later we will discuss if there is any leakage, what is the effect in the electrical machine. So here again discussing about what is the magnetizing curve. I think I covered this one fully in the previous slides, which is here. Okay, so now the question example here. A square magnetic core has a mean depth length of 55 centimeter and cross sectional given. So depth, everything is given. Okay. Uh, 200 turns coil of wire is wrapped around the leg of the core. The core is made of a material having the magnetizing curve shown in the figure below. Okay, so the magnetizing curve here is not the mu r, which is, can you remember the formula? Uh, B equal mu h. So mu zero times mu r. So this graph shows only mu r. Okay, don't forget that one. If I'm not mistaken, uh, is it mentioned based on this value? I can see maybe mostly it should be mu r only. Okay, how much current is required to produce 0.12 Weber of flux? Okay, the flux also again, uh, the phi is is given. Sorry, the phi is given. So ask you the current I. How we should calculate that one? It is not a tough. It's very easy. Then what is the core's uh, relative permeability? And finally, what is the reluctance? So, okay, how we can calculate this one? Again, we should return back to the formula. The formula said MMF equal R times phi, H times L, N times I. This is I, okay. N times I. Then in the case, what we know the flux, correct? We know this one. This one is given 0.012. And then ask you uh, current, and N also is given. N is 200. So the easiest way is to calculate what? Is to calculate reluctance R for me. Whatever I can see, the next part expectation is to calculate this one at the second round, but I can easily calculate this one. As we know, is L over mu times A. So L, we know 55, correct? Yes, 55 centimeter. So 10 times minus 2. The A also given 150, 150. 10 minus 4. Mu is mu 0 times mu r, correct? How we can calculate mu r? We should return back to B equal mu h, and phi it's B times A, correct? So we know phi, we know A. We can calculate B by here. Okay, we know this one, we know this one given. So the B is here. So from this B, which more or less is highlighted by here, you can find the H, which is here. Okay, so based on the calculation, I think I missed the this one, not this one, not this one. Okay, I have to calculate by myself, it seems. Just in my view, okay, my calculator is here also, so let me calculate. Why not? Phi is 0.012 divided by A, which is 150, 150 in minus 4. The value is 0.8. The B is 0.8. So the B is given by here 0.8, which is exactly here somehow. Okay. So it's over 100, less than 150, which is here. So we can assume it as a the H. So B is 0.8, 0.8. Okay. Then H, based on the graph, using the graph, we should mention. If you answer such a this question in the exam, don't forget mention based on graph. Okay, based on graph, H equal the H is 130. Okay, if you like, you can make it 135. Okay, I just put it 130. So based on these two value, B mu H, the mu can be calculated from here. Mu is B, which is 0.8 over H, which is 130. So by this value divided by 130, it's it's a very small value, which is 0.062. Am I correctly place this value? B equal mu h, B equal mu h, correct? Where is it? Should be around here. B is 5 over A. I calculate that one, yeah. Then H from here is B over mu, okay, B over mu, and I think it's correct. So right now the mu is very small for me. Okay, whatever. Let me continue. So the value is it wrongly? Maybe I should convert it to not sure. 0.006. Okay, 0.006. Then uh then this is the mu r, correct? Or the whole mu. I think the whole mu. If it's whole not mu r only, mu, which is mu 0 times mu r, this one, yeah, I think this one is a total mu. Okay, the total mu. So we can replace it by here. times 150 e minus 4 what times 55 e minus 2. So this value 0.062 is 0.0062 is considered for whole. No need to times it by the mu 0. Okay, the A is 150 something. I mentioned this one. So the total reluctance value here is equal 5958. Assume 5958 point something point three point three. So this is the total value. This is the total value of what? This is the total value of reluctance, correct? So still we don't know what is the current, correct? So here, right now, we know the R, which is this value, reluctance, correct? And we know N. So from this equation, you can calculate I. What is the value for I? I is equal maybe I can go through this way 0.012 times 5958 divided by what? Divided by 200. So from here you can calculate the current. Okay. Part B, mu r. So as we know mu r is mu divided by mu 0, as simple as this one. So mu is 0.0062 divided by mu 0, which is 4 pi times 10 minus 7. Then based on this one, I think I receive a good value, 0.0062 divided by 4 pi e minus 7, my calculator. Oops, correct. I should mention it times e minus 7. This one working? Yes. Yes, correct. So the mu r value is 4933 point. This is point 8. And what is the reluctance? So the reluctance also calculated by me. Okay. So maybe you can calculate the h. What is the value for h here? How we can calculate h? So it's very easy. You know L. L is given. So for part to part, you can calculate h. Okay. Next, control delete. Okay, good. Next question is example. Different graph. Also we have, as you can see. So this is the value. Let me just zoom in and see. So we have H and B, and this value is for different type of material. One is steel, one is cast steel, one is cast iron. So these three given. So different graph, different value. Again, for this example, is given what the givens are. Okay, figure represent the magnetic circuit. The number of turns is given. N is given as a 500 turn, correct? And the mean core value LC also given is 360 millimeter. So right now 10 minus 3, done, finish. When the air gap length is the air gap lengths, each one is 1.5. So LG, each one is 1.5 kilometer millimeter, correct? 10 minus 3. Flux density is 0.8 Tesla. So B is given 0.8 Tesla. Type of core is given is a cast steel. So cast steel is the middle one. Find the current. So it's look like the example of what is the current. So again, I should start with the MMF. Don't forget in the exam, you should write down the formula Ni equal HL equal RV, R5. So, okay, right now I know phi. Phi is BA. Reluctance also, so this one can be calculated. L also I know. N also I know. So from each one, I know one. Very good. The I need to be calculated. And this one, a part is given. So this is the best we can go through the calculation. How we should do the calculation? We know B. So using this graph, let me zoom in. Uh-huh. So B is, the value is 0.8. So 0.8, the cast one, the cast still, don't. Then the value is between 400 and 600, which is 500. So using the graph, here mentioned graph, don't forget again, based on the graph, H is equal 500 ampere turn, or correct, 500 ampere turn divided by meter. So done, finish. And then mu can be calculated through this equation, mu, which is mu, which is B over H. The B value is 0.8, H value is 500. So 0.8 over 500, correct? Okay, the value of this is given. Next is reluctance. 1 over mu times 1, no, L over mu A. But don't forget, we should calculate RC. Then we have 2 RG, correct? We have 2 value for RG, the same value, but we have 2. So you can see here is mentioned 510. So you can see this is based on the graph. It's not wrong, but accuracy is up and down. Uh, here said MMF in the core is H core times LC. So H core, you calculate it here, 500. Okay. Then using this formula. So it means that this guy is going to using KVL on behalf of KCL to calculate that one. So the length also given. The length is here. Yeah. The question was, what about the H? The H for gap. We know the H for this is the H for core. What about the H for gap? Is it the same? Of course it is not. Okay, of course it is not. So how we can calculate the H? Let me change the color. How we can calculate the H for gap? H for gap, uh, from the main formula, which is B or something. So B is constant. Okay, B is constant in the core. We cannot change the flux, the flux in density, correct? The flux density still is 0.8. Okay, but here on behalf of mu r, we should put mu 0. If you place mu 0 here, the h become hg. Then you can calculate the, where is it? It's hg. Okay, hg is here. Don't forget we have 2 air gap, as I mentioned. Still have 2. the same as 2R is to the 2H. So the whole calculation here is 0.8 over that one. The value is given times LG. Then using this formula, for this formula, don't forget we need a summation of whole reluctance, which is reluctance of core plus reluctance of air gap plus reluctance of other air gap. You can see here reluctance of core, this one plus this one. See, core is considered as this one since here until here, then again here to here. These two parts, are separate. One, two. Sometimes it is possible in the exam I give you this part plus this part separately. So in this example, the whole length, average length is given to you in one, which is 360. So in the exam, I can give you 300 plus 60 or other values. Finally, MMF, when we calculate the MMF, we can easily find out the the current, which is 4.19. The next part asks you compute the values of permeability and relative permeability. So the same as something I mentioned before. These two value 0.8 over 510 here. Yeah, it's here. So this is the relative one. The relative permeability is mu over mu zero. If you divide these two value, which become 150. Done. Finish. And if the gap is zero, what is the current needed and required by here? What is the value for the current? Okay, in this case there is no air gap, just HC LC is MMF and then divided by N, which is here you can find it. How small is the current? The current become you can see how small compared with the air gap. Air gaps usually has the biggest reluctance, so the reluctance need the biggest value for current. Okay, thank you.